we can use the enthalpies of formation or the heat of formation is we were using the equation that the change of enthalpy of the products, enthalpy of formation of the products minus the change of enthalpy of formation of the reactants will always give us the change of enthalpy of the reaction. So let's see, and let me add all these up, add these up. So the difference between these two will tell us the change of enthalpy of reaction, which means if we know all of our numbers except for one of the enthalpies of formation, we can solve for that too. So in this question, we have the change of enthalpy of the reaction at standard conditions. And we have, let's see, I have the enthalpy of formation of H2S, hydrogen sulfide. I have enthalpy of formation of the water. And I know this one because that's saying how much enthalpy is released when you form a mole of silver from the element that would make silver, which is just silver. In its standard state, well, it's going to be a solid under standard conditions. So this is 0. We're making silver from silver. There's no reaction there. Same with oxygen. Oxygen is a gas under standard conditions, so there's no change of enthalpy there. So I have all the enthalpies of formation except for silver sulfide. And that's what I'm going to solve for. You might want to pause right now and write down the equation and all the enthalpies of formation and the enthalpy of reaction. Pause. Do you have it? Okay, I need more space. That's why I had to go to a new slide. So I'm going to use this equation, plug in everything I know, and solve for the one thing I don't know. So let's see. I had 4 moles of silver. So the enthalpy of the products, one of the products was silver. And the change of enthalpy of formation for those 4 moles of silver is 0 because it already is an element. And the other thing I was making was the H2S, and I made 2 moles of that, and the enthalpy of formation of the hydrogen sulfide is negative 20.6 kilojoules per mole. All right, and the third thing I was making was oxygen gas, which is already an element as a gas at standard state, so its enthalpy of formation is 0. And then I subtract the enthalpy of formation of the reactants, and the reactants were this silver sulfide that I don't know. I started off with 2 moles of it, so my unknown is the enthalpy of formation is silver sulfide. And let's see, also water. We had 2 moles of water. So we put in the enthalpy formation of the water, negative 285.8 kilojoules per mole. And we said that all of this added up to equal the enthalpy of the reaction, which was given, and it was 595.6 kilojoules per mole, and I'm using kilojoules per mole because that's how many kilojoules would be released if I had 1 mole, or if I had the mole amounts given in the equation. So I'm going to go ahead and add these up, and I get negative 41.2 kilojoules per mole is released if I form those products from elements. Get the difference for how much enthalpy would be released if I form the reactants. And that would be 2x. And that's 571.6. And all of that equals the 595.6 kilojoules per mole. So I'm just going to get the 2x alone. And so what I'm going to do there is I will add 2x to each side. And then I can see I have negative 41 plus 571. Probably the most common mistake with these problems is people forget that this is negative 2x plus 571. And I'll subtract 595 from both sides. So I end up with 2x, enthalpy formation of the silver sulfide, is equal to, actually, I just doubled it on my paper, negative 65.2 kilojoules per mole. So I just want to solve for x, and I can say that the x is going to be equal to negative 30 2.6 kilojoules per mole. So that's how many kilojoules are released if I form 1 mole of silver sulfide. Whenever I have a math problem this long and there's positives and negatives involved, there is a good chance that I have made a mistake. So what I would do to make sure that I did this right, I would take this negative 32.6 and I'd plug it in right here. And I would make sure that this side really was equal to this side. And I did check it and it worked, so now I am happy.